A plane is flying within sight of the Gateway Arch in St. Louis, Missouri at an elevation of 25,000 feet. The pilot would like to estimate her distance from the Gateway Arch. She finds that the angle of depression to a point on the ground below the arch is 19 degrees. Please round your answers to the nearest foot. A. What is the distance between the plane and the base of the arch? B. What is the distance between a point on the ground directly below the plane and the base of the arch? Okay, the first thing that I want to do is go back and start to pull information out of this. And I'm going to draw a diagram to help me better visualize what's going on. So I know that I have the Gateway Arch. And it doesn't matter how good your diagram is. It doesn't even have to be very good, and mine's not going to be. I'm just going to rough these out. And I know that I'm looking at a point at the base of the arch. I'm going to put it at the center of the arch. The problem doesn't tell me exactly which direction the plane's approaching, so we're just going to assume some things. Then I'm going to draw a plane. Now, it's not going to be a very good looking plane. I'm just throwing this out here. And my pilot's going to be up in here. Now, what do I know? The plane is flying at an elevation of 25,000 feet. So that's important. And notice that I've drawn a line directly straight down from the plane to the ground. I also know that if the pilot is looking on the line of sight, the angle of depression is 19 degrees. That angle of depression is right here. And this distance right here is going to be the distance between the plane and the base of the arch. Notice that I've already labeled it as an H because we are using right triangle trigonometry here. There's a number of different ways to approach this. Okay, I know that this right here is going to be a right angle. And if this is 19 degrees, the complement of that, because when I have a right angle and I bisect it with a ray, I'm going to have complementary angles. So I'll take 90 degrees and I will subtract 19 degrees from that. And I'll get 71 degrees. Now, I'm going to complete my triangle. This is a right triangle. I know that this angle right here is 71 degrees, which means that this angle over here is 19 degrees. You'll also note that this angle inside the triangle and this angle exterior to the triangle or external to the triangle is 19 degrees. And that's because this H is a transversal. It's intersecting two parallel lines. And so what we have is these alternate angles, and they are going to be congruent or equal. Now, let's go ahead and actually find the values that are being requested, because I know that this is my opposite side and this is my adjacent side. And I know that I'm going to use trigonometric relationships. The first thing that I know is that the opposite side is 25,000 feet. I'm going to be looking for the distance between the plane and the base of the arch, which is H. I don't know what that is yet, but I do know that I have an angle theta, which is equal to 19 degrees. And so what I'm going to do is choose the correct trigonometric function that's going to help me solve this. I'm looking for the hypotenuse, I'm given the opposite side, and I know what the angle is. That relationship is using the sine function. The sine of theta will be equal to opposite over hypotenuse. I know that theta is 19. and I know the opposite side is 25,000. And now I need to solve for h. And what I'm going to do is swap the h and the sine 19 degrees. Basically, what I'm doing is multiplying both sides of the equation by h and dividing both sides of the equation by the sine of 19 degrees. Now, I want to plug this into my calculator exactly as it's written out. The reason that I want to do that is because I want to leave the calculations to the very end, if possible, so that I can do the most accurate calculations. So, when we do that, we end up with the following. And notice I'm using the approximately because this is going to be an irrational number. So 76,788.83717. Remember, I need to round this to the nearest foot, so that means that the plane is 76,789 feet from the base of the arch. Well, that's our first step. The second one is, what is the distance between a point on the ground directly below the plane and the base of the arch? Well, I've already established this point directly below the plane. And here's the point at the base of the arch, and I note that that's my adjacent side. I know that I have the angle theta, and I have the opposite side. So I'm going to use the tangent function, because I know that the tangent of theta is going to be equal to the opposite over the adjacent sides. I know that theta is 19 degrees. I know the opposite side is 25,000, and so we have tangent 19 degrees is equal to 25,000 over A. I'm going to use the same principle that I just did to find the hypotenuse, and what I'm going to do is go ahead and swap A with tangent 19 degrees. Again, I'm going to plug this directly into my calculator as written, and then I will go ahead and round it once I have done that. So 25,000 divided by the tangent of 19 degrees is approximately 72,605.27194. Once again, I'm going to round that to the nearest foot, and that'll be 72,605 feet. And so, remembering that this distance is 76,789, I know that this distance is 25,000, and this distance is 72,605.